Hello and welcome to Algebra 2, Chapter 3.1. Today is the start of Chapter 3, Systems of Linear Equations and Inequalities. And 3.1 is solving linear systems by graphing. So keep in mind, a system is multiple equations or inequalities considered at one time. And we're going to be discussing linear systems, so everything here should be a line. So we're going to be discussing systems of two linear equations. So that is two equations that have the same two variables. Keep in mind that you have to have as many equations as you have variables. So if we have two variables, we need two equations. If we had three variables, we would need three equations. And our solution is going to be any ordered pair that satisfies both equations. So that means it must work in both. Graphically, that's the point where the two lines would cross. So the first thing we're going to do is just check to see if these ordered pairs are a solution to the system. We're going to check them one at a time. They must work in both. So if it works in the first one, you have to try it in the second one. So if we try 1, 4 in the first one, we're going to get 1 minus 12 is negative 11. That's not negative 5. If it doesn't work in the first one, you don't need to try it in the second one. So let me try let me try negative 5, 0. So negative 5 minus 3 times 0, that would be negative 5. So that equals negative 5. That one works. Just because it works on the first one, so all I'm doing is plugging in x and y, and that is 10. There we go. So that's just a check. So if we graphed these two lines, they would cross at that point. That's what that would mean. So a graphical representation of two lines, you can actually get three different types of solutions. So number of solutions, we can have one solution, and that would be when two lines are going to cross. And if two lines intersect, they have to intersect exactly once. You can't have two lines that intersect exactly twice or exactly 3 times. If two lines intersect, they intersect once. We can have no solution, and that would be if the two lines are parallel. Since their solution is the ordered pair they share, parallel lines would not share any ordered pairs. Or you can have infinitely many solutions, and that's actually if they are the same line. So when you would graph them, they would be the same line, they would share every point, and thus we say it has infinitely many solutions. So solve by graphing, you're just going to graph both equations on the same coordinate plane. Up to you if you want to graph with a table or slope-intercept form. I might suggest slope-intercept form. So I'm going to take the first equation, I'm going to move the 2x to the other side. I'm going to divide by negative 2. Y equals x plus 4, and I'd probably go ahead and graph it. 2, 3, 4, oops, and it's a positive slope. Now, one thing with these is you might not draw on your line yet, because your lines don't always tend to be dead on accurate, and so if you just plot some points at the moment and then come back later and draw on your line, because you might need to count your slope more, because at the moment you don't know where they're going to cross. Or if they're going to cross. Alright, so let's look at the other one. Subtract 2x. 2y equals negative 2x plus 4. Divide by 2. Y equals negative x plus 2. So that one starts at 2 and a negative slope. Now, there's no real reason to count this way. So I'm going to count back the other way. There's my solution. Alright, two things. First of all, if it says solve by graphing, you have to have the lines graphed. So we need to go ahead and draw the lines in. Okay, that's your work. You must have it. Then your solution is the ordered pair where they cross, and they cross at negative 1, 3. That is your solution. You must have that part. The graphing is your work. Okay, and you can definitely check it to make sure. That would be negative 2 minus 6, which would be negative 8, and negative 2 plus 6, which would be 4. I would always advise you to check it because your graphs just don't always tend to be exact. Okay, we're going to look at another one. Okay, so graph them, and that shouldn't be any problem. I'm going to subtract x. You could also add y and then move the 5 over. Let's see here, divide by negative 1 to get rid of that. Okay, so I'm going kind of quickly here because the concept isn't graphing a line. You should know graphing a line. Alright, so there is that line. And then the other one, subtract 2x from both sides. Negative 2y equals negative 2x plus 9. Y equals positive x minus 4.5. That'd be a negative 9 halves. So I'm going to start at negative 4.5, which is going to be right there, and go up 1 over 1. And what's happening here? They are parallel, oh so close to each other, right? Those lines are parallel, and you could probably tell they're parallel before you graphed them. How could we tell they're parallel? Well, I shouldn't have circled the x, I should have circled the number in front of the x. Same slope, right? Same slope as parallel. So if they're parallel, what is your solution? It is no solution. Or you're welcome to use the symbol for no solution. Alright, we'll finish everything else up in class. Let me know if you have any questions, and have a great day.